All right, so now we're going to be working with some word problems related to the Pythagorean Theorem. We have Steve who is turning half of his backyard into a chicken pen. His backyard is a 24 meter by 45 meter rectangle. So here's Steve's backyard. A rectangle has 4 right angles here and 24 by 45 meter. He is going to put chicken wire fence along the west side of the yard, which is this side, and the south side of the yard, which is this side, and along the diagonal connecting the northwest to the southeast part, which is this here. So this blue outline created a blue right triangle here, and we want to figure out how many meters of fence Steve will need to fully enclose this area. So basically what we want to find is the perimeter of this blue right triangle, but we need to figure out what this blue diagonal length would be, and that's when we're going to use the Pythagorean theorem. That blue diagonal is across from your right angle on this blue right triangle, so this is your C, and I'm going to label my 24A and my 45B, and now I'm going to use that Pythagorean theorem. 24 squared plus 45 squared is equal to C squared. A 24 squared is a 576 plus a 45 squared, which is a 2025, and that will equal C squared. Adding 576 to this, I get a 2601 is equal to C squared. And taking the square root of both sides, the square root of a 2601 is actually a 51. That's your C. Now we don't need to, that's not my answer, we don't need to find just C. We want how many meters of fencing Steve will need to fully enclose the area of that blue fence. So we're finding the perimeter of that blue fence, which would be 24 plus a 45 plus a 51. Which a 24 plus a 45 plus a 51 comes out to be a 120 meters. And that's it for number 1. Moving on to number 2. If we have a 650 centimeter ladder that's placed against a building at a certain angle that reaches a point on the building that is 520 centimeters above the ground. So for example, here's my building. The ladder is what I'm drawing in red. It's leaned up against the building. The ladder is 650 centimeters, and that ladder reaches up the wall to this point here, 520 centimeters above the ground. So that's 520. If the ladder is moved to reach a point 80 centimeters higher up, so now we're saying that the ladder is 520, is reaching a point 520 plus 80, which is going to be 600 feet up along this wall. The ladder's still 650 centimeters. That does not change. The length of the ladder does not change. We want to figure out how much closer will the foot of the ladder be to the building. So this is the foot of the ladder. And in this situation, I don't know the length of this. I'm going to label that as X. And same in this situation, I don't know what this length is. I'm going to label this as Y. But I want to figure out how much closer is Y compared to X. So I'm going to need to do the Pythagorean theorem twice. In my first diagram, I'm going to label my 520 as A, my X as B, and my hypotenuse, which is the ladder, as C, because this is your right angle here. And then in my other diagram, I'm going to label my 600 as A, my Y as B, and my 650 is still c, because again, this is your right angle here. And I'm going to do the Pythagorean theorem twice. So on my first diagram, I would have a 520 squared plus an x squared is equal to a 650 squared. On my second diagram, I would have a 600 squared plus a y squared is equal to 650 squared. And I'm going to find x and y. So 520 squared is going to be a 270,400. And then this is plus x squared is equal to, and a 650 squared is going to be 422,500. In my second equation, a 600 squared is a 360,000 plus y squared is equal to, and again a 650 squared was the 422,500. All right, subtracting the 400 from 422,500, I get that x squared is equal to 152,100, and taking the square root of both sides, I would wind up with x being 390 centimeters. Subtracting 360,000 over from both sides in my second equation, I would wind up with y squared is equal to 62,500. And taking the square root of both sides here, I wind up with y is equal to 250 centimeters. So we want to know how much closer is y compared to x. So if I do 390 minus 250, I wind up with the base of the ladder is 140 centimeters closer. And that's your answer. All right, moving on to the next one. I have the town of Easy is mapped on a coordinate grid with the origin being at the statue before City Hall. KFC is located at the point 37 on the coordinate grid, and McDonald's is located at negative 37, and this should say McDonald's. How far is it from KFC to McDonald's? So what we want to do is we aren't given a graph, so what we're going to do is we're going to find the rise and the run. Now the rise is the difference from your y values. Well, from a 7 to a 7, that's a rise of actually 0. And from your run, that's a difference between your x values. From a 3 to a negative 3, that's a difference of negative 6. But remember, side lengths on a right triangle can't be negative, so we're going to take the positive version of negative 6, and it's just a difference of 6 here. So I'm going to label one of my legs A, my other is B, which technically you can't have a right triangle with a leg of 0. But on the graph, this is actually just going to create a straight line. So if we did have a graph, we could easily count how far the two are. But we don't have a graph, so we're going to use the Pythagorean theorem to help us find C. So I'm going to do A squared, which is a 6 squared, plus B squared, which is a 0 squared, is equal to C squared. I wind up with a 36, and then plus a 0 squared is just going to give you that 36 is equal to C squared. And if I take the square root of both sides, C comes out to be 6. So we don't know what units, if it's in feet, meters, miles, so we're just going to put 6 units. All right, number 4. Mr. Smith wants to store a 12-foot long pipe inside of a cardboard box, which the cardboard box measures 6 feet by 6 feet by 8 feet. When it's written like this, that's in terms of length, width, and height. So this is a rectangular prism. Here's how we draw a rectangular prism. We first draw ourselves a rectangle. All right. From the top of the rectangle, we draw kind of like a diagonal here. And then we draw this horizontal a little bit past the top corner, and then we draw that down. Then we draw a vertical, but not all the way down, because now I'm going to connect this with a horizontal. And then now we draw in our dotted lines, which this comes back like that, and then up here, and then in the back. Remember, the largest length in a rectangular prism is the diagonal of your box. So if this 12-foot pipe would fit in the diagonal of the box, then technically it does fit in the box. They're saying the pipe should fit inside the box from the front right corner all the way through to the back left corner. So like this. We want the length of the box's diagonal in inches, and we want to see if the pipe's going to fit in the box. So I'm going to label that diagonal as D. Now to find that diagonal, I'm going to use this vertical line and this horizontal, well, this isn't a horizontal line, but this bottom of my box, and this is technically our right angle here. All right, and remember the length of this box is 6, the width of the box is 6, and the height of the box is 8. So this yellow line is 8 on that right triangle with the blue diagonal, and this pink line down here, we don't know what that is, so I'm going to label that as C. So on the right triangle that creates the diagonal, we don't have enough information to do that one yet. So I'm going to use this purple right triangle here to help me find C. So I'm going to label one of my 6's A, my other 6 B, and I'm trying to find C. So I'm going to do A squared plus B squared equals C squared. So I have a 36 plus a 36 is equal to C squared, which gives me a 72. Taking the square root of both sides, since this is not a final answer, I do not need to simplify the square root of 72. In fact, it's easier not to simplify the square root of 72. The only reason why we can do that, though, is because this is not a final answer. We will simplify our final answers. So the square root of 72 is C. So now I'm going to use this blue right triangle where the D is my hypotenuse. I'm going to label the square root of 72 as A and 8 as B. So I have the square root of 72 squared plus 8 squared is equal to C squared. The square root of 72 squared is just 72. 8 squared is 64, and this equals C squared. 72 plus 64 gives us a 136. Now, we do not report lengths of a box in terms of a word problem in simplest radical form. I never say, oh, this is, 2 root 4 or 2 root 5 inches. Instead, we're going to round this one, and I'm going to round it to 11.7 inches. Now, if the diagonal of the box is 11.7 inches, that's actually smaller than the 12-foot pipe. So when it asks you, will the pipe fit inside this box? No, the pipe will not fit inside of your box. All right, that brings us to the end of this